Hi there. Today we are looking at question 7, another problem from the 2024 November paper 2 exam. Okay, let's get straight into it. So we've been given a diagram that has the graph of f of x is equal to tan x. And we are shown the interval where x is an element of values between negative 180 degrees and positive 180 degrees. And this is what our tan function looks like. So in 7.1, they want us to write down the equation of the asymptote of f in the interval. And the asymptote is the line in which our function is avoiding. And for this graph, it's these two lines. But within this interval from positive 0 to, well, 0 is always positive, from 0 to positive 180, it's the x is equal to 90 degrees line. So 7.1, x is equal to 90 degrees. 7.2, they want us to write down the values of x in the interval from negative 180 to 0, for which f of x is less than or equal to 0. So less than or equal to 0 means we're looking at where it's negative or 0. So here at negative 180, it's exactly at 0. And then from here, it's negative. So that means we need to have two answers. So the first answer, x needs to be negative 180, or it should be between negative 90 degrees and 0 degrees. We're not going to include the 90. We're not going to put an equal to sign here because it is an asymptote. Okay, you can also write it as x is an element of values between negative 90 degrees and 0. And then you put a square bracket. Okay, moving on to 7.3.1. We've been given the graph of g of x is equals to cos 2x plus 1, and they want us to write the period. So to determine the period of a function, so here we're looking at cos. The standard cos graph has a period of 360. So what we do then is our 360, we divide it by the coefficient of our angles, and for us that's 2. So we're going to divide that by 2, which gives us 180 degrees as the period of that new cos graph. And then in 7.3.2, they say on the grid, we need to draw the graph of g within this range from negative 180 to positive 180. And we need to show the intercepts with the axes as well as the coordinates of the turning points. So we're just going to draw it over here. I'm going to remove this highlighting. So we are looking at the graph of cos that has been shifted. So the easiest way to save time is, well, you can draw a table with the x and y values and then draw it and join it, or a quicker method is to use the standard cos graph. So I'm going to show you how to draw this cos graph and then sort of do the shifts, and then you'll be able to get the new graph of cos of x. So we already determined the period, it's 180. So that means our function needs to complete its wave from 0 to 180 over here. And then we need to do the same from negative 180 to 0. And then it has also been shifted 1 unit upwards. So we know the normal cos graph is has the maximum at 1 and the minimum at negative 1. But if it's been shifted upwards, it means that the range is now from 2 to 0. Okay, So what that means is it's going to start at 2, and then this 90 is now the new 180, and then this 180 is now like the previous 360, because we now shrunk it. So you end up with something that looks like, okay, let me add 45 here. So at 2, it's now hit its maximum. At 45, it's going to be at 0. At 90 degrees, I'm getting confused by all these dots. At 45, it's now at 1, not 0, because it has been shifted upwards. And then 90, which is the new 180, it's at 0. And then 135, it's back here. And then 180, it's back at the maximum. So then we can join. My curve is not very smooth. There we go. And then we just do the same thing on the left. So negative 45, that's when it's at positive 1. 90, it's at 0. 135, it's back at 1, somewhere there. And 180, it's at 2. There we go. This is now the graph of G. So because I already know what the normal graph of cos of x looks like, I was able to then draw this one with much ease, taking into account the fact that the period has changed and it's been shifted 1 unit upwards. Okay, they said we need to write down the clearly show intercept to the n, write down the coordinates of the turning points. So the coordinates of the turning points are there at 90, so it would be at 90 degrees and 0, and 0 degrees and 2, and then the other one is negative 90 degrees and 0. Okay, moving on. Excuse me. They said use the graphs to determine the general solution of 2 cos cubed minus sine x equal to 0. So we first need to simplify before we need to simplify it such that we can start to recognize the functions we already know, which is the one for G and obviously tan. So let's try to see 7.4. So the equation is 2 cos cubed x minus sine x is equal to 0. So we can take sine x to the right hand side. So now we've got a positive sine x. And if we divide both sides by cos, we can end up with a tan x. So divide by cos x here and cos x there. Now here we are left with, on the left, 2 cos squared x, and on the right we've got tan x, which is good because tan x is one of our functions on our graph. Okay, so now it's this 2 cos squared x, and we need to find a way to make it look as cos 2x. Now cos 2x is a double angle. So what we can do is we can try and manipulate the left hand side such that it looks like the double angle identity. So all that's missing actually is the negative 1. So what we can do is we can subtract 1 from both sides. that will have us that will lead us to have this -1 here, and here we also subtract -1. Now the left hand side looks like our double angle identity, which is cos 2x is equal to tan x minus 1. And now we can take the 1 to the left because that will look like the graph of G. So cos 2x plus 1 is equal to tan x. So now we can see our two functions. This is the function of f. It's not showing. This is f. And then over here we have got G. So what we are looking for when we're looking at the graphs is where does G intersect with F? That will help us to get the solution for this problem. Okay. Now looking at our two graphs, they intersect over here and over here. Yeah. And we haven't been given a range, so we just need one solution, and then that's it. So interpreting from our problem here, where we're trying to get the general solution, we are looking for where cos 2x is positive, and it will also be equal to a positive tan x. And we find that occurring over here. And we said over there, that point that's at 45 degrees. My sketch isn't the best, but it's right in the middle. So that is, we're assuming it's around 45 degrees. And that will therefore be our general solution for every 180 degrees. So therefore, x will be equal to 45 degrees plus k dot 180 degrees, where k is an element of integers, because we also see the same in the range between -180 and 0 over here. We see that same pattern. So it means that this intersection is happening every 45 degrees when we look at every 180 degree period. And that's it for question 7.